So this video is a follow-up to my previous video showing you how damage dice work in Dungeons & Dragons, Pathfinder, various RPG systems. What I want to do in this video is show you behind the scenes how I created those graphs. And I did it using this VPython code. I've got 3 videos planned to go over this. The first one, this video, is going to show you how you can use this code to make your own explorations. So without really going into all of the nitty-gritty of the loops and everything, if you just want to use this code, this will show you how. Part 2 is going to show you the library that I made to support this program. That's this dice library that's being imported here, because that library will let you do more than just this code. And then the third video will show you all the details of how I made those graphs, how this code works. So if you just want to use this code, if you just want to make your own dice histograms and explore the different distributions and things like that, all you need to do is download this code. And actually, I'm going to try to have this available in GlowScript so that you don't have to install Python to run it. You can just run it on glowscript.org. But I'll also have the source code available in case you prefer to run it on your own machine. What you need to do is you need to scroll all the way down to line 113. So right here where it's got this big block of comments that said begin user edits here. Unless you're wanting to change what the code does, you don't need to change anything above these hash marks here. And all you do is follow these instructions here. So the first thing you do is create a dice combination using this function, D, and then it has 2 numbers, number of dice and number of sides. So if you are wanting to make, like we did at the end of that video, 8D1, which I'll admit is a kind of a ridiculous dice combination, but you never know. Your GM might introduce such a kooky weapon, or if you're a GM, you might want to introduce such a kooky weapon. So what you would do there is you would enter this command D with arguments 8, 1. And then in order to create the graph of that dice combination, the histogram like we saw in the video, you use this command, this make stats. And all you have to do there is provide it with a color. So VPython comes with several preset RGB colors. So for example, color.yellow, color.red, etc., etc. I don't know the exhaustive list of those off the top of my head, but if you Google VPython colors, you can find out what all of those are. And so then here you just continue with it. So for example, this next command creates 4D2. So this is going to give you 4 two-sided dice. So this is going to be 4D2. This next one is going to be the flip of that, 2D4. So 2 4-sided dice. This one is going to give you 1D8. Again, just like in the video. Oh, this is actually from another video I was working on. Let me just get rid of that. That one will be coming out next, working on critical hit rolls. And so what this does is the 2 commands do each do half of the work. The D function creates a set of dice. It adds dice to this list. Then the make stats command creates the graph. And at the end of that, it clears the list of dice that you've created. So after it runs this, it removes those 8D1. And then when you run this one, it removes those 4D2, etc. So it gives you a couple of outputs. It gives you this graph here. So these are the histograms that we saw last time. You'll notice that they don't have the fancy little graphics. I haven't figured out how to import those into VPython yet, so I was using Excel to create those. But what this does, in order to help you understand what it is you're seeing, it gives you a little legend over here. So I figured out how to create a legend in another video, but I haven't imported that over to this code yet. So what it does is it tells you that you've got 8D1 over here in the yellow, and that matches what we saw for the 8D1 last time. It's 100% at 8 and 0% everywhere else. Here it tells you that if you've got 4D2, that'll give you the red distribution. That's a distribution like we saw again last time for 4D2. Same thing, green here gives you 2D4, so a little bit shallower peak. And then the cyan gives you a single D8, and that's the flat distribution like we saw before. And then I also have it calculating the average and standard deviation for you. just so that you've got that information handy. This code also exports these results to text files named after these combinations. So there will be a file called d4 plus d4.txt that contains all the data you need to graph the green d4 graph. It'll have a d8.txt that'll have all these cyan data points in it. And they're all text files so that you can import them into Excel or whatever your favorite spreadsheet program is. So that's pretty cool. This is what we saw last time. So just to help demonstrate how to use this, I thought it might be fun to run a different scenario. Oops, that's not what I meant to do. I meant to hit... let's comment all of this out. I don't want to lose it, but I also don't want it to run on top of everything else. Let's take a look at possible ways to get 12. Last time we looked at possible ways to get 8. Possible ways to get 8. Let's look at possible ways to get a maximum of 12. So the first one that comes to mind, of course, is that you have a single D12. So I put in the number of dice that I'm working with, and then I put in the sides of that dice. So I've got D1, 12. And now that by itself is not going to do anything. If I run the program, it's just going to spit out to end of program because it's the makestats command that gives me the actual graph. So I'm going to say makestats color dot, let's just go with the same order we had before, color dot yellow. So what this is going to do is this is going to make a graph, a histogram for a single D12 using yellow data points. It gives me my little reminder here that yellow is the D12. It tells me the average is 6.5, so that's right in the middle of this distribution. And the standard deviation is 3.5. Of course, it's kind of hard to imagine what a standard deviation means on a uniform probability distribution. At least I find it difficult to visualize that. But just like we saw in the video, a single die is going to give a uniform probability distribution, assuming your die is nice and balanced. Another way to get 12, of course, is you could take 2d6. So then I can do makestats color.red. So that little argument gave you a reminder of another way you can do the color is you can use a vector to describe red, green, blue, or you can just use some of the prefab ones, color.red. So let's take a look at 2d6 versus 1d12. So the 2d6 is going to be in red. Kind of like we saw before, having 2 dice, gives you this wedge shape. And so again, you have a lower probability of getting the maximum damage, but you also have a lower probability of getting the minimum damage and a higher probability of getting average damage. And also you notice the average is a little bit higher because you don't have a minimum of 1 anymore, you have a minimum of 2. Playing around with our factors, there's more ways to get 12. I can roll 3d4. That's pretty fun. Let's do makestats color.green. And this is a nice way to build this study, is to just add one graph at a time, add one histogram at a time. This one again is wedge shaped, but you notice it's got a little bit of concavity to it because initially these first 3 dots have actually they've all got a different slope, don't they? So these two have a slope, these two have a steeper slope, these two have a steeper slope, and then it starts to level out here. So you're getting, again, more concentrated around the average. So again, the average goes up because you're getting a higher minimum, but also that standard deviation is decreasing. So you're hitting the average more frequently or with greater reliability. We can keep going. We can roll 4d3. Let's make those stats cyan, color.cyan. Now, of course, our graph's getting a little more complicated. Again, you notice this is getting more squish, but it's also getting some concavity to it. It's starting to look a little bit more Gaussian-ish, right? So it's got some tails going off to the side here, and then it goes up more sharply, and then it comes rounded off here. So that's pretty cool. You can also see the progression of the average. So here, or at least where the peak is. Here you got a peak at 7, and we know from here, actually we know from here that is the average, right? Here the average is 7.5. Here the average is 8. Okay, so the peak does correspond to the average, at least for these cases. Let's try one more. Let's try 6d2. We know what 12d1 is going to look like. That's so artificial. It's kind of boring. Let's see. We have yellow, red, green, cyan. Let's go with regular blue instead of cyan. So this is going to be 6d2. 6 two-sided dice is going to give you the blue graph, and that's very, concentrated right there, right? That's concentrated around 9. 62 is something that's something nice to roll. That would be a nice weapon to roll. So that's how you use these. Is you just put in the dice command that you want, and then you tell it to make stats based on the color that you want. You can try out various combinations. You can do all of the standard dice combinations that are given in the standard table. You can try making up your own combination. So if you wanted to, design weapons for a homebrew, you can do that here and get an idea of what the distribution is like. One other thing you can do, you don't have to use the same sided dice for each possible roll. So for example, another way that I could get 12 would be to have 3 4-sided dice and 4 3-sided. No, wait, that's not going to work, is it? 2 3-sided dice and 3 2-sided dice. There we go. I was looking at the wrong spot on my notes there. So this will give you 6. So this will give a max of 6. And this will give a max of 6. So you imagine you've got a weapon with, some enchantment or something, enhancement, excuse me. It probably is enchanted if it's doing this. You imagine you've got some weapon that's got some enhancement to it that it deals, multiple types of dice. So it's doing 3d2 plus 2d3. That'll also give you a max of 12. Let's make those stats in red. You have to put color dot in front of the color name. There we go. And that produces something interesting too. That's kind of similar to the type of thing we've seen before. So yeah, you can make those different combinations. They don't have to be the same type of dice. So this is 3d2 and 2d3, and it'll take care of all of those in the make stats routine. Now, one thing I haven't found yet, I've been playing around with this. I haven't found a dice combination that produces 2 peaks in the distribution. That's one of the things I'm pretty sure you can't get, but I don't know how to prove that you can't. So if you find a combination of dice that gives you 2 peaks in the histogram, definitely let me know on Twitter at Let's Code Physics, or let me know in the comments below. That would be a wonderful follow-up to find if you could get a distribution that had 2 peaks to it. Anyway, next time we'll take a look at just what this D function is doing. We'll get an idea of this library that I've made and what it does for you. And then in part 3, we'll take a closer look at the make stats command to get an idea of how this is working. So if you wanted to change up how the combinations are calculated or how the graph is displayed, you could do that. So thank you so much for watching. I will see you next time. Bye-bye.